Good afternoon, class. So you guys had, we said in this lesson we're going to look at the revision exercise. There was 3 sums that we haven't done yet, which is 2, 3 and 4 on page 242. And I gave you a sum or two of proportionality, the converse thereof. No? So we're going to look at that as well today. So this is the revision exercise. Revision exercise on page 242. Okay. This was the revision on grade 11 work. Right, the question says O is the center of the circle. So if O is the center of the circle, what do we know? We know many things. Okay, we know that angle at center is twice the angle at circumference. Okay, I'm just going to align the board again. Okay. Still on the right, but okay, it's better than before. So we know that A1 is double A1 would give you a 1. Okay. What else do we know? We know that OB is equal to OC, radii, which is resulting in B1 equal to C1. Angles opposite equal sides. Okay. Then when we are told that STU is a tangent at T. So if that's a tangent, what do we know? We know that T3 is equal to U2 and T1 is equal to C3, tan chord theorem. Then we are told that chord BC, that chord is equal to chord CT. If that's the case, what do we know? We know that angle A1 is equal to angle A2Y. Equal chords subtends equal angles on the same side. So that will get the same marking length. You see that? Then we are told that CTU is 40. CTU is 40. So that is 40, this is 40, that is 40, this is 80. This can be worked out, that can be, many angles can be sorted out. Can you guys see that? So, let's look at that quickly. So, we have 40 degrees there. So, the first question was to calculate A2. So, A2 is going to be 40y tan chord theorem. Okay. A1 is also 40.
My apologies for the interruption. So C2, Makingwana in 12C. Can you please make your way to the office immediately? So C2, Makingwana in 12C. To report to the office immediately.
Equal angles on the same side. Angles on the same side. Equal chords subtends equal angles on the same side. Okay, I think I must take a calculator already. Question C, they want you to work out angle B1 and B2. B1 and B2. We have T2, B1 plus B2 plus angle T2 will be equal to 180 opposite angles of cyclic chord. We have that, but I don't have T2. Okay, so back to the drawing board. B1 and B2. I can work out, I can definitely work out B1. Okay, B1 I can work out. No parallel lines. Yes? Oh, I missed it. ATC. A. Right, this is 105. Thank you, no? So that means to say, as I indicated, that B1 plus B2 plus 105 now was equal 180. Why? Opposite angles of a cyclic chord. Okay, so the B1 plus B2 is equal to 75. The reason here is opposite angles of cyclic. Okay, so this whole angle here is going to be 75 degrees. Okay. But now we want to know C2. Take us away. We're going to keep the diagram in focus. Okay. So D. At this point we can work out O1. Okay? We can work out B1 and C1. Then we can go with sum of triangles. And that's how we'll be able to pick up C2. Can you see that, people? So let's go. Firstly, angle O1. Angle O1 is going to be 2 times 40, which is 80 degrees. Angle at center is twice angle at circumference. Okay? So this is 40 degrees. Angle B1 is equal to angle C1. Why? Angles opposite, equal sides, and that's your sides or your radius, your radii. Okay? I'm interested in C1. I could have named B1 and come back and say it's equal to C1. But I need actually C1. Okay? So B1 plus angle C1 plus 40 equals 180. But we know that C1 and B1 is the same. So 2C1 plus 40 is equal to 180. Why? Yes? 80. Did I write 40 here? 80. I wrote 80 in there and 40 there. Sorry man. 80 there. And the reason there? Sum of triangles. And it's triangle BOC. So angle C1 works out to be 180 minus 80, which is 100 divided by 2 is 50 degrees. So C1 is 50. Right? Now what? Now we can go with the fact that sum of triangles, the big triangle. So it's going to be 40 plus B1 and 2, which is 75, plus C1, which is 50, plus angle C2 is equal to 180. Why? Sum of triangles, and this triangle BAC. Angle C2 is equal to 180 minus 90 is 90, minus 75 is 15 degrees. So you see 15 degrees? Sorry, C2. It's 15 degrees. Any confusion there, people? The sum is worth quite a bit of marks, no? Or is there an easier way of doing it? Was there an easier way? You follow the same route. Okay. Let's go to number 2. 3, sir. We did the one already, so it's 3. Number 3. ALB is a tangent to the circle LMNP. ALB is parallel to, so if ALB is a tangent, what do we know? We know that L3 is equal to P1. Why? Tan theorem. And also L4 is equal to M1. And this is the combination of L1, of 3, sorry. What's the 3 here? Yeah. The 3, the combination of 3 and 1 is also going to be equal to P1 and 2. Okay. The combination thereof. And many other things. Okay. Then we are told that ALB is parallel to MP, sorry. Lines are parallel, what do we know? Alternate angles are equal. So that angle is also equal to that same marking there. Which then in turn means what? That LM is equal to LP. Why? And sides opposite equal angles. Can you see that? Without reading anything here, we can already see what they're going to ask us. What they could ask us. Okay? And of course the other way as well is no corresponding, but they could be co-interior. But I don't see the need to highlight that here at this point. Okay. The first question says, prove that LM is equal to LP, and we just did it now. Can you see that, people? But so it's very important to read what is given. So we are told that, so we say, let L3 equal x. Do we have to introduce an x here? No. But if you want to work with an angle with no x's, it's fine. It just make it life a bit easier for us. So if L3 is x, then P1 is also going to be x. Why? Tan theorem. Okay. So P1 is x. Okay. What else do we know? We know that M1 is equal to angle L3, which is equal to xy. We see these alternate angles here. Alternate angles with AB being parallel to MP. So there's an x there. Now we state the obvious. We say since M1 is indeed equal to P1, which is equal to x. Therefore, LM is equal to LP. Why? So we got sides opposite equal angles. We have sides opposite equal angles. So now I can fill it in on the diagram that those lengths are indeed equal. Okay. So then do is I'm going to take this off. So again, to keep the diagram in focus, to answer B. We must prove that in B, that Ln by 6 MNP. So that means to say that M1 is equal to N2. If we can prove that N1 is equal to N2, we've done the job. But what is N1 also equal to? XY, the bow tie there, the butterfly. N2 is equal to also XY, angles in the same segment again. Not so? So there we've done the job. Now it's a matter of writing it out. We say that N1 is equal to x. Why? Angles opposite equal sides. No. Angles in the same segment. Angles in the same segment. And it's coming from arc LM. There is an x here. Okay? Then we see that N2 is equal to x. Why is N2 equal to x? Same story. Angles in the same segment, LP. Angles in same segment, and it's coming from arc LP. Okay. So now we say, since, we state the obvious, since angle N1 is equal to angle N2, which is equal to x. Therefore, Ln bisect. What does bisect mean? So cut the angle in half. Bisect angle, or we can rather say MNP. Okay. Therefore, Ln bisect angle MNP. Okay. Which means to say, therefore, yeah, Ln bisect. It's correct. Alright. So it means to say that that line cuts that angle in half. And then you see, it says LM is a tangent. LM is a tangent to circle through M in Q. So if this was a tangent through that circle, if that was a tangent, then what do we know? That this angle would have been equal to that angle. So to prove that that is a tangent through that circle at the M, we then need to prove that that angle is equal to that angle, which is marked out already, not so. What do we say? We start by saying, let's take it circle. Okay, this is, so we said again, the tangent to the circle at M. Okay. So we say since M1 is equal to angle N1 which is equal to x, that's proven already. So therefore, Lm is a tangent to circle at M. And what's the reason for this theorem here? What's the reason? It's either the converse of the tan-cot theorem, no? We're using tan-cot theorem in reverse, or angle between line and chord equals angle in the alternate segment. So angle between line and chord is equal to angle in the alternate segment. That's the converse of the tan-cot theorem. If you have written the converse of the tan-cot theorem, you would have gotten full marks there anyway. Okay? So that is number 3. Let's move on to number 4. Revision exercise number 4. Page 242. So here we are told the figure alongside RQ and RB are tangents at Q and B respectively. What does that mean? Respectively, that RQ is referring to Q and RB is referring to B. Respectively means in that order. Okay? And I'm going to align this board now, just in case the video stops or anything else. Okay, so I'm just going to work with it like it easier. Okay, and so you put your number 4. So I can move this over. Okay. So we are now told in the then the circle center radius BO produced. Produced means extended. Meets a circle at A and RQ produced at P. RQ, there is RQ at P. The first question, we are told that let L1 equal x. Q1, sorry. Let Q1 equal x. To the next thing. Okay. Here's a tangent. They are tangents. So if these are tangents, people, then I know that Q1 is also equal to B1. Not so? Why? Tan chord theorem. We also know that Q4 is equal to B21. Angles opposite equal sides. Not so? Because QR is equal to RB. Why is QR equal to RB? Tangent from common point. Tangent from external point. Okay? Right, the question says prove that. Take us over here. Let's prove that RBOQ is a cyclic quadrilateral. How do you prove cyclic quads? You prove it one of three ways. Either opposite angles are supplementary, or exterior is equal to the exterior angles for the interior opposite of the quad, or exterior angles equal to the interior opposite of the quad. Okay. So this is your radius here, not so? So that is 90 degrees and this is 90 degrees. Radius perpendicular to tangent. But if that is 90, then that is also 90, angles on a straight line. Or radius perpendicular to tangent. So you see that that's your exterior angle and there's your interior opposite. So that means you say this is a cyclic quad. Make sense, people? If you don't see it, what you should be asking yourselves, if that was a cyclic quad, what could I have said? Then those three things comes into play. Not so. So to prove it's a cyclic quad, I prove that one of those three properties are evident. Okay. Let's go. We're going to firstly say in A that it's going to be 90. So O, B, R. Or I could have said angle B1 plus B2 is equal to 90. Why? Radius perpendicular to tangent. Okay? Q1 and 2 is X, which is OQP or PQO is equal to 90. Same story. Radius perpendicular to tangent. So since that angle, so you say since, we state the obvious. Since OQP is equal to OBR, which is equal to 90 degrees, since that is the case, therefore Q RBOQ or BOQ is a cyclic quad. Why? Because your exterior angle equals the interior opposite angle of quad. The exterior angle is equal to the interior opposite angle of a quad. Okay? People are some like this worth 4 marks. Okay, so don't take this light-heartedly that if you don't understand, just leave it. Some's worth a lot of marks. Okay? And if you think 4 is not a lot of marks, then you need to get your child self-checked up, no? Very important. Let's get everything we can get. Okay? So now, since that's a cyclic quad, all cyclic properties are evident there, which means to say that Q3 will be equal to R2. Q1 or R1 sorry is equal to B1. And O3 is equal to Q4 and so on and so on and so on. Why? Because that is now a cyclic quad. You guys understand? Right. Let's go to B. Let's go to B. Name with reason 4 other angles in the figure which is equal to X. People, that sum could be worth be worth 8 marks or something. Okay. So with reason 4 other angles in the figure which is equal to X. So Q1 is x. We said B1 will be x. Why would angle B1 equal to x? Tan chord theorem. Okay. So you put an x there. Then we said which other angle is equal to x now? Huh? Q3. Why? Oh, Q3, I'm looking here. Sorry, Q3, you are absolutely correct. Q3. So Q3 is equal to x. And Q3 is equal to xy. She's saying angles opposite equal sides. And it's your radius that's coming into play here. Not so? Which other angle is equal to x? Sorry? R1 is equal to x. Yes. Why? Why is R1 equal to x? Oh. R1 is equal to xy. Angles in the same segment, not so? And it's coming from arc. Arc QO, OQ. If you don't want to write that, you don't have to. There's no marks involved. Then R2 is x. Why is R2 x? Sorry? Angles in the same segment. And it's coming from arc. Arc OB. Can you see that? R2 is equal to x. I'm not going to put the angle there. I'm not going to struggle now with this thing. Angle in same segment. And it's coming from arc OB. Where else do you see OB? What does OB remind you of? Ocean basket, no? Yeah, someone have listened now Ocean basket, no? And I know it's not that time of the month. So, no. People, the question says, express t in terms of x. Express p in terms of x. So here's your angle p. Okay. So, what do we have here? Okay. Here's a triangle. We have angle P, 1 being x, Q3 is x and 19a, Q1 and 2, and we got angle P. Can you see that, people? So angle P plus 90 degrees plus x equals 180. Reason? Sum of triangles, and is triangle PQB. You don't have to name the triangle. So therefore angle P is equal to 180 minus 90 is 90 minus 2x. Okay. 90 minus 2x. Okay. Any confusion there, people? Alright, let's carry on. What was the next thing I gave you guys to do? So that basically brings us to the end of the revision exercise on page 242. Then I gave you on page, what is the other page? The other exercise. Yesterday we did proportionality, no? Why are you paging so frantically through your books? It should be on the last page now. Yes, page 275. We did number 1 yesterday, no? Number 2, I gave you for homework. Right. Then we said the balance we're going to do through, I'm going to do it on videos, and I gave you the references as well, no? The other class started with the trigonometry. So we are like 3 periods behind them. 3 lessons. So we must really get a move on, no? Otherwise they're going to get better average in our class. They're almost there, no? But anyway, this is exercise 7 on page 275. What's it? Exercise 7, eh? Okay, so we are told that in the triangle TRP, so it's TRP, the big triangle, QR is 9.6. So QR is 9.6. TP is 4.5. TP is 4.5. PS is 1.5. Is odd. Okay, is odd is 12. SQ is 4. SQ is 4. And TS is 3.6. Okay. Right, the question says proof. So what do we work out? We work out ST over QR. Then we go with TP over RS. Then we go with ST over RS. And where do I get that? I get it from here. Okay. Sorry? I said SP over QR. Yes, that's correct. TP over RS. And SP over QS. Okay. So ST is ST 3.6 over QR. Sorry, 9.6. So that's going to give us 3, 1 over 3. No, 3 over 8. Then we go with TP. TP is what? 4 over 9. 4,5 is over RS 12, which is also 3 over 8. Not so? Then we say SP, that's going to be 30,5. Is that correct? Huh? SP. Oh, it's 1.5. Sorry. Over QS 4, which is 3 over 8. You all okay with that? So below that we write ST over QR equals TP over RS equals SP over QS equals 3 over 8. So therefore triangle STP is similar to triangle QRS. Why? Because the sides in proportion. Sides are in proportion. Okay. So now all cyclic, not cyclic, but proportionality, what's the name, works here now. No? Similarity certainly works here. Let's go with B. Okay, I'm going to just take this off because I want to keep the diagram in focus. Okay. B. We must prove that PT is a tangent to the circle. PT. PT is a tangent to the circle through TSR. 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 So we must prove this here. So again, if that was a circle and TP was a tangent, then what would we have known? T1 is equal to angle R, tangent theorem. Not so? So now to prove that that is a tangent to a circle going through there, we prove that those angles are equal. You understand? So let's go. If we look at the two triangles in question, it was is TP and QRS. QRS. Can you see that? So that means to say that angle S is equal to angle Q. Angle S is equal to angle Q. Angle T is equal to angle R. Angle T is equal to angle R. Can you see that? So there we have that already equal. And where is it coming from? The fact that the triangles are similar. Does it make sense? So now we go. Say, okay. You're saying that T1 is equal to angle R. Why? Because triangle STP is similar to triangle QRS. Okay. So you can say corresponding angles are equal. Okay. So now we state the obvious. We can just say since that was the case, therefore TP is a tangent through circle TRS. TRS. Why? Because angle between line and chord equals angle in the alternate segment. Okay? So that is now indeed a tangent to the circle. Okay? To that circle here. And I take this off. Nothing's going my way on this board. And then we didn't use blue. They want you to prove that SQ is parallel to TP. SQ is parallel to TP. Okay? So how do you prove lines are parallel? You either prove that corresponding angles are equal, alternate angles are equal, or coincident angles are equal. But if we look here, can we prove this angle is equal to that angle? Yes. Also coming from here. Not so. Because STP is this triangle here, and QRS is this triangle. Not so. So this angle P is equal to that angle S3 of that triangle. You don't see that, people? You see the link? Okay? Take this back. So we're saying that angle P is equal to angle S3. And where are we getting that from? The fact that triangle STP is similar to triangle QRS. Okay, so that angle is equal to that angle. You can even say since. Just stating the obvious. So therefore, TP is parallel to QS. Why? Because corresponding angles are equal. Okay, now we can put the parallel lines going through like it. Okay, and then lastly, the last question, we are required to prove that TQ is 1.2. TQ is 1.2. TQ, so where is TQ? There is TQ. Now you see these lines are parallel. So if lines are parallel, those lines are parallel, then we know that TQ over QR is equal to PS over SR. Whenever you got parallel lines, look for those things, okay? Your proportionality theorem can be applied here. So you say TQ over QR is equal to PS over SR. And we're getting this from the fact that it's a proportionality theorem with QS being parallel to PT. Okay, this is the most important thing to say. Okay, it looks more already on the board, but for now, for this now, TP. The really bad handwriting, the board is now messing us up further. Okay, so TQ is what we're calculating over QR. 9.6 equals PS, PS which is 1.5 over SR, which is 12. In other words, that must be taken up. So therefore TQ is equal to, on your calculators, 1.5 times 9.6 divided by 12. Yes? Sorry? 1.2. Right. So there we go, 1.2. Okay? Was there anything else that I needed to answer today? No. Right, for homework. We're back at the Platinum textbook. And you will be doing for homework is you'll be starting out trigonometry. Is not Platinum textbook? Okay. Again, your trigonometry. It's out of your Platinum textbook. It's on page chapter 5 on page 90. So for homework, I would like you to do the revision exercise on page 91. Revision exercise on page 91. Okay, we're going to run through those, what's the name, tomorrow. Okay, so please do the homework so that the first half of the lesson doesn't go to waste and you didn't learn anything from that. Okay, so your homework is exercise 1 out of the Platinum textbook on page 91. People, you may pack up. We have a couple of minutes, 2 minutes left, 1 minute.